Okay. Example 6. I do not intend to go through example 6, but I just want to very quickly highlight what do we mean by the term independent of x. Right? The term independent of x, that means the constant term. Right? That means the constant term. That means i.e. x to the power of 0 or the constant term, which is here, right? I do not intend to go through, really, seriously, I do not intend to go through. You can read it on your own. Okay, this O-level stuff. Okay, you can go and find out which one is the constant term. Example 7 is the one I want to go through next. Alright, find the coefficients of x to the power of 5 and x to the power of minus 3 in the expansion of this. Now, shall we then take note that there are two binomial expansions here? Okay, there are two binomial expansions here. There are two. The second one, this one, was already from example 5. So we're going to copy and paste here. So far so good. That's my example 5. You've done it. Right? The first expansion, x plus 1 over x. Where's my pointer? Here. Okay. The first one here, we're going to do it here. Shall we? Just very quickly do it together then. Alright? So refer to the formula. First one should be x. Oh, why am I using red pen? Wait. Blue. Red pen is scary, right? Don't use red. Oh. X to the power of 4 plus 1 x to the power of 3 1 over x. I'm sure you guys can continue, right? Can you just refer to the formula list? Too much talking, thank you. Can you continue, please? On your own, don't need to look at me. Continue. Plus 4 2 x squared plus 4 3 x 1 over x cubed plus 1 over x to the power of 4. Okay, the close bracket section. Alright. All okay? Can this O-level stuff, yeah? So, assuming we can expand, we get here. This one and this one. Now, how do we get the term containing x5 and x minus 3 here? Of course, you could have 1, 2, 3, 4, 5 terms, 1, 2, 3, 4 terms. They expand. You get 20 terms. You want to do that? Of course not. Were you taught to do that at O-levels? Of course not. Now, how do we find x to the power of 5? You don't have to expand every single term. You just have to pick out the expansion. Which term times what term will give you x to the power of 5? Which times which will give you x to the power minus 3? Let's do this together. Which one? What times what will give you x to the power of 5? Now, there's no way you're going to get x to the power of 5 with, say, this and whatever, this. Correct? This times this will never give you x to the power of 5. No. This will give you 1 over x. So, let's look carefully. I'm sure you know, you can get x to the power of 5 with x4 times x here. Follow what I'm saying. x4 and x. Any more? X squared and x cubed. X squared and x cubed. Any more? I do not think so. So therefore, this times this times this will give you minus 3. This times this will give you 4. So, minus 3 plus 4 will give you 1. Now, could we do the same for x to the power minus 3? There are seats in front, latecomers. here, 3 seats here, 2 seats there, 5 seats. Don't disrupt the others. Hurry up. X minus 3. I'm going to erase this. Don't want to mess up my diagram. Okay? X to the power minus 3. You can have this times this. You can have this times this. And you can have this times this. There are 3. Do you follow? 6 times 1 over x cubed. You remember the negative. This one is x to the power minus 3. This is also x to the power minus 3. This is also x to the power minus 3. So, you get minus 6 plus 12 and minus 3. You get 3. Follow? All good? Any questions? All okay? All okay. Good, huh? I'm going to go through quite fast. Okay. That finishes the revision bit, the O-level bit. There's a binomial expansion for what? For powers with positive integer. Alright? At the start of the lecture, I mentioned there is this. We're going to do something like that. Wait, this one, I delete first. This is my own notes. Wait. Okay. This next part is different. It's something I've not seen before. Wait, I think I better stop the video and then we start. This is a clean cut. Pause.